Hi, this is another example for reciprocal functions, how to get their graph with multiple factors involved. Here, on the previous example, we had only two factors, and now I'm adding up a third one, which is this one, the x minus 6. Just as a small guide, we have to start out by finding out these three elements, the horizontal asymptote, the vertical asymptote, and the y-interception. Actually, the first one is pretty straightforward, pretty easy. Horizontal asymptote will be, in this case, y equal to 0. Let's move to the vertical asymptote, but first I'm going to draw the horizontal asymptote. The horizontal asymptote will be around here, y equal to 0, all along the super nice vertical asymptote. Okay. Now let's move to the second step, getting the vertical asymptote. The vertical asymptote, basically, we take each of the three factors in the denominator, these three guys here, and we equalize each of them to 0, equal to 0, x minus 2 equal to 0, and x minus 6 equal to 0. Then we solve all the x's. So we got here the x equal to negative 2, x equal to 2, and x equal to 6. Now these three will be three vertical asymptotes. Vertical asymptotes. I'm going to draw them quickly. I apologize in advance because I'm going to draw it very ugly way. Here is my negative 2, and now I'm going to draw the second one here in the 2. Here is my super nice asymptote. Now on the 6, be around here, all the way down here. Okay, there are my three super nice vertical asymptotes. Now I'm going to move to the last step, last thing here, the y-interception. In order to find the y-interception, we just have to evaluate our f of x with the value of 0. F of 0 will be here. I'm going to substitute the x with 0 in each of the factors. 0 plus 2 times 0 minus 2 times 0 minus 6 all over 1, and we'll get here that this is just the same as having here a 2 times a negative 2 times a negative 6. Now these two multiplied would be a negative 4. Negative 4 times negative 6 would be a super nice 1 over 24, and this will be my y-interception. Y-interception. Now I'm going to draw it here in the graph. 1 over 24 is just nearly 0. I'm just going to locate it in here. It's positive and it's slightly above 0, and that will be it with this for this y-interception. Now we have to proceed to do this. I'm going to repeat pretty much the same process from the previous example. I'm going to pick a couple of values just for each of the asymptotes. Here in the negative 2, I'm picking a couple of values. There are these two. One is slightly bigger, one is slightly smaller. For the 2, I'm doing the same thing here. One is slightly bigger, one is slightly smaller. And with the 6 as well, which are these two. And now at the end, I'm adding up here these other two. In this case, I'm adding up a super big number positive. And in here, I'm adding up a super big positive and super big number that is negative. Now, in here, I'm not going to write actually in here the results of these numbers, these operations, these substitutions, because to be honest, the only thing you have to be concerned is with the sign of the result, because in every case, at least in the first 6, you will always get a super big number. The only thing that makes the difference is the sign of the super big number. I'm going to write only the signs here. At the end, if I evaluate these, I'm going to get a super big and negative number. That with a second one, a super big and positive number. With a third one, super big and positive number. Then super big and negative, super big and negative, and then super big and positive. Now, with the last two, oh, sorry, this is too ugly here. The last two, when you evaluate a super big number positive and a super big number negative, in both cases you will always get a result which is almost 0 in both cases. Almost 0. That is to say, evaluate 1 over 100,000, you will get something really close to 0, but the only thing you have to be concerned is with the sign of this almost 0 in both cases. And the first one will be almost 0 positive once you evaluate it, and the second one will be almost 0 negative. That is to say, this one is slightly above 0 and this is slightly below 0. Now I'm going to draw this, what this represents on the graph here. Just starting out with this one. This, if we get to the -2 slightly before -2, you will get a super big and negative number. Now after the -2, you will get a super big and positive number here. And with the +2, if you approach with this value slightly smaller than 2, you will get a super big and positive number. Now after the 2, slightly after the 2, you will get a super big but negative number, which is this here. And with the 6, slightly before the 6, you will get a super big and negative here. After the 6, you will get super big and positive. Now, if you evaluate something that's number is super big number, you will almost 0 but positive. That is slightly above the x-axis around here, which makes sense because we cannot cross out this horizontal asymptote. And now, with an almost super big and negative number, you will get almost 0 but negative. That is to say, slightly below the x-axis on this part of the graph. Slightly below the x-axis. Now the only thing left actually is just to join up these arrows. This one will have to be something like this. Remember, we cannot cross the asymptotes. That's very important, not crossing the asymptotes. And here we have to be concerned with touching here the y-interception. It's very important here, and that's mandatory. And as after that, we go along here. Remember, not touching the asymptotes. And with this here, we get something like this. Super nice. And with the last one, we get something like this. Okay, that will be it for this graph. I'm just going to show you how it would look like with the Desmos. It's in here. As you can see, it's basically the same thing I have in my graph, just I think mine is of course nicer. That's it with this video, with this example.